As it says right here, designed for lightweight agentic workflows, simple data extraction, and applications where responsiveness and API costs are the primary constraints. This is super.
The useful takeaway here is not that a cheap model beat every frontier model at coding. It did not. The interesting part is narrower, cheap, fast models are getting good enough for structured extraction. If your workflow is scrape a page, clean it up, extract JSON, validate the result, then repeat 1,000 times, latency and cost matter more than raw benchmark status. The stack is simple. Use a reader layer like Gina to turn a messy page into Markdown. Send the full clean page to Gemini Flash Lite, ask for structured data, then validate every URL, image, product field, or entity with code. That last validation step is the important one. Without it, you are still just trusting a language model to make up links confidently.
However, when I realized this, I fixed this and I did the real test here, which unbelievably, right? And this is super, super unbelievable. 96% of the URL, 96 out of 96 URLs that were returned were 200, right? As in 200 code. So they are real, right? 36 out of 36 URLs returned HTTP 200. You guys, this is crazy, honestly.
That is the point worth caring about. A cheap model becomes valuable when the output is easy to check. Links can be fetched, images can be probed, JSON can be schema validated. You are not asking the model to be wise, you are asking it to do cheap perception over a large chunk of text, then letting deterministic checks catch the failures. The audio and video input claims are interesting, but I would not make them the first use case. Start with pages. Text extraction has the cleanest feedback loop, the easiest retries, and the clearest cost math. Once the page pipeline is stable, then test audio transcripts or video frames as separate jobs.
Now, one thing just to note, guys, is grounding, okay? Grounding is basically using Google search as Perplexity does, for example. And we do a lot of this inside Harvard as well. It's probably our main expense, to be honest with you. The problem with grounding is it's per query. So just bear this in mind, okay? If you're using grounding, you need to tell the model to only do one query or two queries, because otherwise it'll do 30 queries. And my God, the costs are insane. We went from spending like $10 a day to $150 a day, which luckily I noticed and stopped. But just if you're doing grounding, just be extremely careful, okay? It's probably not worth it. It's probably much better to do just traditional LLM scraping instead of...
This is the part people will miss. Grounding feels safer because it uses search, but it can destroy the economics if every extraction turns into a pile of hidden queries. For most scraping products, use retrieval yourself. Fetch the page, normalize it, pass the exact context. Only use grounding when freshness is the actual product, like keyword research or market monitoring.
Now, I just want to return to this quickly. 96 URLs were real here, and 36 out of 36 images were also real, right? So I just want to reiterate this point because these are not easy links. So you can see the test here. I did this with Claude Code. It basically just said set up the scraping system and then test the URLs to see if the URLs that are given back from the LLM were real, right? This is the actual test that I gave it. This was a really, really good test for me personally. For context, the likelihood that GPT-5 Nano will hallucinate one of these links is about 50%, right? Which was our old method of doing this. I upgraded to Gemini 3 Flash because Gemini GPT-5 Nano was just too inconsistent and its hallucination rate was way too high. Even with Gemini 3 Flash, the hallucination rate was about 75%. So to have 100% real URLs here is extremely interesting at a very, very good price and with a million context. This is probably the best new scraping model on the...
My checklist would be this. First, pick one narrow extraction target. Second, save the raw page, the markdown, the model JSON, and the validated result. Third, measure cost per 1,000 pages, not cost per prompt. Fourth, retry only the failed fields instead of rerunning the whole page. And fifth, Keep a bigger model in reserve for edge cases. Flash Lite should be the worker, not the judge. So yes, this is probably a real upgrade for LLM scraping, not because it replaces the whole stack, but because it makes the boring middle cheaper, read messy pages, extract structured data, validate hard, and move on. The trap is treating a cheap model like magic. The win is treating it like a fast extraction engine with tests around it.